All right, everybody, welcome. Thank you so much for coming. I see a lot of repeat faces from the last couple sessions, which is awesome. Hopefully, this will be sort of a linear progression. Um, if you do end up feeling a little bit lost today, always feel free to ask questions in the chat, as well as use the Discord in general later to talk with other workshop participants and Callum figure stuff out. But remember, you can always go back and watch Zeke's workshop last weekend too on our YouTube. That'll give you a good fundamental sort of base. But yeah, don't worry at any point if you kind of get lost. We'll try and touch on everyone's issues and make everything go smoothly. So thanks so much to Callum for joining us. Callum is working on Howl right now, as well as helping out with a couple other protocols here and there, including Spark. And I'll probably let you do an intro of maybe what you specialize in and what you like to do in the coding world, but basically smart contracts, CosmWasm master here. So today I think he's going to walk you through a demo of making an actual contract for like an app, and should be awesome. So without further ado, I'll let Callum take it away.
Yeah, so hi guys, I'm Callum. As Timmy said, smart contracts is sort of what I do in the ecosystem, and just to give a little background on what that actually is, it's Rust programming, which Zeke gave a great introduction to, and smart contracts is of course just code that runs on the blockchain. So effectively what we'll be writing is something that you could upload to a smart contract enabled chain, more specifically one which supports CosmWasm 1.0, which is sort of Juno, the main ones Terra 2, and yeah, basically that. And just so we want to start from, as I've seen a couple people had a few difficulties setting up. Now I can't run through this, but this is something that I need to talk through because it is a little bit on the complex side. So firstly, I'm just going to go and preface this that if you're on Windows, I would definitely recommend setting up Windows language server or Windows Server language, where you can download other OSs and just use Ubuntu. So this is I'm just going to quickly plug a link in here. But yeah, so basically, because it's quite leaned into the Unix setup, I would just recommend you can just use, Subsystem, that's it. I am blanking on the name because I've just used a Unix machine for ages. But this is what I'd recommend to set up. It's super simple, and there's people that have explained it a lot better than I ever could. Reason being, just a lot of the bindings for Windows are just quite bad, and the command line just isn't as good. And then once you have a Unix terminal set up,
one question I might throw in here, Callum, I know a couple people have asked me this and I said I don't know. WSL, Windows Subsystem for Linux, versus dual booting versus virtual boxing. Like, is WSL separate from virtual machine and dual booting? It's its own thing?
So yeah, dual booting would be a completely different partition that you'd have to, set up with you'd have to partition your drives. So if you ever installed an OS, it'd be physically running them sort of simultaneously, and then when you boot your PC, you'd choose. This just gives sort of a pretty nice, easy way to do it. And then a VirtualBox machine is also doable if you want to boot through VirtualBox or whatever, but WSL is probably the most consumable that I've been exposed to. So once you've got WSL set up, you could actually rent like a box on Dotion or a cache and just SSH over, but that's outside the scope. And once you've set up with a Unix terminal, we're going to be following this section here. So firstly, we're going to go through and just going to drop a link here. You should just be able to run this command direct in your WSL Ubuntu terminal, and that'll install all the Rust tooling you need. It's literally a one-liner copy-paste. And just so you know that WSL, it'll open up the terminal, so you'll just have to paste commands in. And then if we go to the docs here, you can see these next snippets is what you need to run. And this is the reason, if anyone was on Windows, I don't blame you for getting stuck. The Windows setup sucks. So just don't bother, just install WSL. But I'm going to drop a link to these docs now. And just quickly, did anyone have any issues with Unix setup or anything they want me to explain, just feel free to drop a message or even speak up if you're that way inclined.
People's mics are muted by default, so they'll have to use chat. But if anyone does want to do like a question over the mic, just shout it out in chat and I can unmute you.
Okay, so I'm just going to give it a little bit longer just in case people are typing, which I see someone is. When we install Rust, do we do the default install? Yes, just go with whatever it says. Like it's just, yeah, so that, and then you would run these snippets which are in the docs here under the installing Rust in Linux and Mac headings. And yeah, so definitely use Unix here, and yeah, it's just a lot easier and it will save you a lot of pain because it's just how a lot of the workflows. And then yeah, there we go. So Julius asked a good question. The WASM-D, that's actually completely optional, I believe. That is, if you're more exposed to the SDK side, that is sort of a chain binary. So you know how you run validators, run nodes, and query a chain. That's the base WASM implementation. And there, that specific error is just because you need to install Go onto your Unix command line, which there you go, Reese helped someone out with earlier. And yeah, WASM-D is just a pretty default CosmWasm chain, which just allows you to run your own code. But if that covers everything, then we should be ready to actually jump in and start setting up a project if there is no more questions or if anyone wants any other help. Right, so I'm going to start jumping in now. So when you want to bootstrap a CosmWasm project, first thing you want to do, very helpful repo here, is head to CW template. And this, of course, I'll be assuming that Git is installed here because it's just super useful. So there's the link for that. And then when you scroll down, there is some setup here as well, which I'm not going to run. But if you follow the Rust setup, you just need to paste these commands into your terminal. So if I was to do this, I would, come over here, paste that in, run that, which I'm not going to do. And then once that's done, grab this one, paste that, run that again. Then once you've got that set up, we're going to start sort of bootstrapping the project here. And this line here is what is needed to bootstrap the project. So we're going to copy this. And what this does is cargo generate is something you install there, and basically allows creating a project from a template on GitHub, which this is a template for a boilerplate CosmWasm project. And this is where you name the project here. So I'm just going to call it 0 to Hero. I hope that I haven't taken that name before. And this currently, what this will do, will bootstrap project with some boilerplate code. But what I'm going to do is actually going to make it not generate the boilerplate. And to do this, you can simply add this flag here in the docs. And this just means that I won't be jumping around deleting a bunch of code, which can quite often be a little bit painful. So what this code does is that it goes to the CW template GitHub, it downloads the template. In this case, it uses the minimal branch, which has less code that we'll need to delete to start coding our application, because the default has some boilerplate code, which is a counter contract where you can instantiate it with a number and just keep on adding one. This is actually the contract which made the Juno chain halt, but that's been patched now, so it's all good. So I'm going to hit generate on this, and you will see that it generates some files. I'm going to cd into the directory and just clear my terminal here. And if you ls-al, you should see these files here. So I'm now going to open my editor, which I hopefully have set the font size to. So when we jump across now, you can use any editor here. I'd recommend VS Code. I just use IntelliJ because it's sort of what I've been exposed to before, and it's sort of hard to shake habits. And I thought giving a talk with Vim would be quite painful. So have I just lost anyone with the generating a project? Let's just ask that quickly. If so, that's fine. But just pop up now if you're asked. And if you need to install Git, then there are guides for that as well. But I believe most Unix distros and WSL actually comes with Git as per default. So you should just be able to generate straight away. Right. I'll start talking through the project, right? Is that fine? I feel like hopefully just to keep stuff moving here. If anyone loses any track, then I have it up on a monitor in front of me. Just call me out and just say, whoa, slow down, or just can you repeat that over again? So this just generates all the boilerplate of what you'll quite often be used to as this is your singular contract project. All of your Rust files you'll be editing are in SRC, other than one other, which is in examples, which is schema, which is just to generate JSON schema for your messages, which we'll get to. Don't worry, that file's a little bit out of scope for this. There's a bunch of boilerplates. There is a .cargo folder, which gives you a bunch of helpful commands which just allow you to run via the CLI. You've got CosmWasm to build the WebAssembly file for your contract, which is effectively the executable. Sort of in C++, this would be your .exe file, but because this is WebAssembly. Unit test, which just runs cargo test with some helpful added extras. And then schema, which using the example schema file there, it generates schemas. Then you have some Circle CI and some GitHub workflows. I'm going to skip over that as they're completely optional, and I'm not really pushing this to Git, so they will be sort of out of scope. The .idea one is just a generated folder by my editor, so you can ignore that. The schema is where all the schema JSONs are generated. SRC is, of course, where I've talked upon. Then you've got a git ignore file, an editor config, a cargo lock, and a cargo toml. A toml is sort of outlining the dependencies. So you can see here it pulled in a bunch of dependencies, some of them dev, some of them needed. This just handles it all for you. Cargo lock is the lock file for your dependencies. That's always generated for you. Don't go looking into it unless you know what you're doing. Then the README, license and notice, just sort of some additional stuff for license usage, a notice, and then the README file, which is the exact same as what's in the repo here. And then Rust format, which configures the Rust format linter. So then we're going to go into the SRC folder here a little bit, and lib is probably the entry point because this way you define your modules. So you can see here we have a few modules. We have the contract, which is where all the actual logic of the contract takes place. The error module, which is where you define errors for your contract. Think of that sort of like a 404 not found error on the web. You can define a not found error in here. Helpers, which is just some test helpers defined, which we're actually going to delete because this is out of date for the query that we want. The message, which is where you define your message endpoints, and state, where you define any state that you may store. So what state is actually sort of the underlying storage of your contract, and it probably is a good entry point here to start looking into. But actually, no, we'll go with messages actually, because that is the bread and butter here. And once again, is everyone okay to carry on? Have I lost even more people? Is anyone even here?
I'll just throw in a cool note, just because I'm more on the level of the people watching. These like messages that I think Calum's better talk to is what Zeke talked about last week. So messages make up transactions. And yeah, so if that's like at all a weird concept for you guys, definitely refer to the recording of Zeke's session. He did more of a fundamental breakdown of a lot of the things Calum's going to talk about.
Yeah. So here we go. So this is going to look like a lot of code for you to start with. So there is three main types of messages here. As you can see, we've got instantiate message, execute message, query message. What the instantiate message does is it fires off the instantiate root of the contract, which we will get to, and the instantiation is effectively getting the contract set up and started. Creating a new instance of a contract. If you're familiar with object-oriented languages, this is pretty much consistent with what you'd call a constructor, right? Where you'd create a new object. This, of course, as you can see here, this instantiate message can be created with some values. So if you wanted to pass it an address to save as the contract admin, you could. And we will get to that because we'll be making modifications here. These macros here are basically ways which define how the message can be serialized and deserialized. So this serialize and deserialize means it can be written to and from JSON and binary, which is actually how all the messages are stored under the hood. It's just we use JSON because it's quite nice. Clone, which just allows you to make a deep copy of an object. Debug, which is some debug niceties, and partially equals, which is for some equality comparison, just allowing you to use the double equals symbol for comparing equality. And JSON schema, as I alluded to before, is how it generates the JSON schema files in this little folder here to the left, the counter response execute message.json. So that JSON schema here above instantiate message directly maps to instantiate underscore message.json. And the reason it is like this is because it has just a renameable snake case. So it means that this will be renamed into snake case, and snake case is just new words separated by underscores, all lowercase. This just means it's sort of normalized in a familiar format. So then we're going to move on to, actually, before I move on, anyone not understanding the instantiate message at all? Anyone sort of struggling to wrap their head around that? You'll see where the instantiate message comes in later.
Gotcha. So I think, yeah, just a little bit. I think he's just curious about, like, right here on your coding screen, where did this all come from? What is it? Is this a contract? Is this a project? Is this a template you started with? Is that kind of where you're at?
Yeah. So if I can just jump in quickly. Yeah, this whole project, which is this folder we generated and opened 0 to here at the top here, is a project to make a smart contract, right? A lot of these files outside the src directory are just boilerplate, which is set up for you that you won't need to sort of check. Then if we go, I'm going to start breaking down the lib as a sort of the src. Lib is what you need to define in Rust to sort of build out your project. You define all the files. As you can see, contract maps directly to contract.rs. So then I'm going to go file by file in this bit. So lib is just defining all the files in your project and exporting them. Contract.rs is actually where the coding for your contract happens. As you can see here, it's not filled out yet, but this is where you define the entry points and the logic of your contract using those messages. So you can see instantiate message is set here. And then under execute, you got execute message, and under query, you got query message.
So everything outside of the source folder is kind of, I don't know if templates
it's boilerplate and templates sort of generate for you that quite often you don't need to touch because it's all quite helpful in there for you. Okay. Error.rs is where you define your contract errors. So if you ever have some sort of breaking logic in your contract, you probably want to error out. You can define error types here. You can see this, that it comes with a custom error where you just set a string. And this little macro just resolves the error to a string. So as you can see, custom error val : these brackets mean that this val variable will be set here. So whatever you set that to, this string will expand to. So if we had, I'm just going to write text here to show. If we had an example where this was actually the custom error, it would expand to. If that makes sense, that foo value is then substituted here, which gives you this message. Then helpers, I'm actually going to delete because this is just something that is generated for you and creates some helpers for the contract, which is generated, but because we've chosen the minimal template, it's not needed. So I'm actually going to delete that quickly and just delete it. And of course, because I've deleted it here, I need to just delete it in the lib folder. Quite often, you may want to keep this if it's your first time. Just don't touch it because it's fine. It doesn't interfere with anything. Then, if we go to the message folder, which is where I was, This way you define the messages to interact with your contract, which is what I alluded to in the contract.rs. So I explained instantiate message, which is effectively setting up and creating your contract. I was getting to execute message, which is, if you're familiar with, say, like a web API, this would be an execute message would be your write routes. So this would be your post put in your REST. And is instantiate sort of similar to something like def defined from Python? No, because because that would define a function in Python. It's probably more familiar with the Python constructor, underscore init underscore on a class, because that's how this is how you create a contract. That's how you create a class. And then a execute message, if we carry on with this example, would probably be a route where you set some values up, or you set a value to another value. And then if we go to query message, this is your read routes. So say if you had a value stored, you would and you want to be able to read it, which we will get to. A query message, you could have a query message sort of read value, and then it would return that value encoded in binary. And then I'm just going to delete. No, we need to keep that. Migrate message is outside the scope of this. This is for migrating contracts. We won't get to that. That's quite complex. Leave that for a future session if there is one, or if you want to look into it yourself, you can. This struct here is a custom response value, which is how you return data from a query route. We'll get to this again and we'll rewrite it in our own way. This is just generated to show you this is how you can do that. And then finally, if we get to state, this is all your underlying storage, where you define the storage for your contract. And quite often or not, there's a helpful library, CW Storage Plus, which allows you to store items or maps. And what a map is it maps from one value to another. So a map is something you use in storage to store multiple values, quite often or not. And this just defines a struct which we store in state here. You can see that we define here an item of state. That means this item stores this struct, well, a type of this struct. And it's just created with a storage key. And this storage key is just decoded to bytes for some underlying storage in the smart contract. All storage is prefixed, so you don't have clashes. So basically this storage key needs to be unique.
Just while people type, because I have a question. I actually was just doing about 50 things at once, and I'm going to go back and follow along when I can. But this whole project, did you provide, was that part of the one of the CLI commands you put in the beginning?
Or... Yeah, so this whole project is in the GitHub link. It's this one. I'll repost it quickly if I can find it. It's this one.
I just missed it.
Yeah, and it's all generated in the CW template. It's the cargo generate command. This one or this one, I went with the bottom one because I wanted to not generate too much because it would have confused a lot more people. So yeah, but that's how you generate this. Awesome. So if we're ready to carry on, we're going to jump in and we're actually on the file. So I'm just going to close all the other tabs and just reopen it. So what we're going to do here, as you can see, it has some preset values, this state variable. And I don't like the name state, as this whole folder is called state, and that can get very confusing if you have multiple things stored in state. We're going to rename this to config. And this is because it's stored once and it sort of holds some configuration values of our contract. And we're just going to delete that count and the address that was stored there, because we're going to define our own values. So, and I'm also just going to quickly delete that because we don't need that. And you can see my IDE is screaming at me here, but we'll get to that in a second. But firstly, what we're going to do is in Rust, everything needs to have like a visibility. So we're just going to go pub, which means public, which means you can read and write it directly using accessing it. And what we're building, I'm going to get to that now as we're here, is we're going to build a polling app where it's going to be similar to straw poll, where people can just define a poll, vote yes, no on it, and it just keeps track of it. And people can just come and just vote yes or no on chain. This is a very simple contract. But what we want is, for config, we probably want to have an admin who can delete any poll, because people are always just going to put random garbage in there and quite horrible stuff. So we're just going to define a admin address. So what this is so far is there is a struct config and it has an admin address. And this is publicly accessible, meaning if I had a config variable, I could do config.admin_address like that. We need to type it, which is why there's the red wiggly line afterwards. And what this is going to be is going to be type addr, which is address. And I hope you all know what an address is, but it's sort of your wallet address in this case. It could be another contract, but in this case, we can just assume it's a wallet address. It's your wallet address, let's just say. So this could be something like Juno1XYZ, or any other chain is available. So and then we're going to get to correcting this error here. So firstly, I'm going to rename this because it's no longer called state. So config in all caps. And then we need to retype it so it stores the correct value. And we're going to redo the key here. So I'm just going to talk through what I did there. Quite often with state, this is the variable name of it. Do it in all caps because this stays quite constant. And it's just nice. That's sort of a good way to know it's constant, all caps. It's of type item, and that item stores a config, which is what we've defined up there. And this is just setting it up to be used, which is giving it a storage key, which means in storage, it'll be prefixed by the word config, meaning there'll be no storage clash. So, and any questions on that? Whoa, you've lost me. Just put them down. Anything? Okay, right. Did that all make sense? So after this, I'm going to jump to the message folder, because as you can probably guess, when we instantiate our contract, when we create our contract, we want to set up this config, right? This config needs to be populated with values. So now we're going to jump over to message.rs, but we're not going to jump into it too much. We're only going to be looking at instantiate message, because we're going to start at the start, and that's when you create a contract. So as you know, we defined a config, right? This config is going to need to know, who's the admin, because we set the admin address, right? This is the perfect use case for our instantiate message. So we already have a value here of type string. We're going to let the user pass in an admin address of type string. And this might lose some people here, but why is this here? Why is this string and not address? This is because one thing, the address type, the ADDR, is actually quite misleading. It doesn't perform any validation. So we're going to let them pass the string, and then we are going to validate that it is an address and error out if it's not. So what this means is that you could pass any value in here, but what we're going to do is we're going to perform a little bit of validation to make sure it's an address so that it doesn't break at a later date. And that's all we need in the instantiate message so far. So any questions on that? Did I lose anyone with why is it a string? And did everyone understand why we're giving the instantiate an admin address? Right, so now we're going to switch files, and we're going to switch to the contract file. So if we're following this through, right, the state is what's actually stored on the blockchain. So this is stored in chain. Message is how you communicate with your contract on the chain. And this can be from a front end, from the command line. But in this case, you don't have to worry about that. This is just how we communicate with our contract. And then contract, oh boy, this is where it gets interesting. This is how you actually define what your contract does. So as you can see, let's talk through this, because this is a lot here. There's some imports here that you need just in general, but these are all defined out for you. There's something here called an entry point. And what these entry points are ways for people to communicate with your contract, which, oh boy, maps to these message types. So an entry point, this entry point is the instantiate entry point, and it takes an instantiate message. So we know that this will be called with an instantiate message. Does that make sense? That these are sort of, if you're comparing it to a web API, if you're that technical, these are almost your API endpoints. Instantiate would be to set it up, execute is to write data, query is to read data. So while I'm waiting for Cause Less Harm's response for what he means specifically by that point, I'm going to answer Sporthy's point here, which is, can we create custom entry point? I'm going to read it just in case. I don't know if the chat's recorded. Can we create custom entry points outside instantiate, execute, and query? No, you can't. There are 2 other entry points. Oh no, there's 3 other entry points other than those 3 that you've listed. And these are all defined by sort of the SDK. So instantiate, execute, query are your very simple ones, which is, create the contract, write data, read data. Then migrate is how you migrate contracts, which is if you wanted to move versions. Reply is if you want to wait for a reply from a message, which you'll see, which we won't get into, that's quite advanced. And there's pseudo, which is governance contracts, which is the Unity contract has this pseudo endpoint because it allows governance to interact with contracts. So pseudo is so rarely used because it's how governance interacts with contracts, which very few people are writing contracts for governance to interact with. Although there's probably some interesting things that you can write for it. So, I also covered Cause Less Harm's questions, that's perfect. So we're going to jump into a little bit of coding here. First thing you might notice is, why is these things commented out? So we're going to uncomment them. And the reason being is CW2 is a spec which allows users to define contract metadata. And this contract metadata is the contract name and the contract version. So the contract name is, of course, 0 to hero because I created it with that name. It prefixes with crates.io just because that's what Rust does. And this env reads from the environment of the project and the cargo package version. And where it sources this data is here. So as you can see, 0.1.0. So that effectively will expand to 0.1.0. And we could change that value. We could make it 0.2 or 0.1, but that doesn't matter. That version is used when you migrate contracts. So say if we wrote 0.2, we would have a contract of 0.2 and 0.1, and we'd keep it that way. So the first line of this is we're going to use that imported function that we just uncommented so we can use it. And what this does is it simply takes storage, which we're going to get to on this, which is deps.storage. And then it takes a contract name and a contract version. So I covered a lot there, which I may have glossed over. So deps is the dependencies of our contract. And what deps mute means is that it's mutable. So we can write to it, we can change it. That's what mute means. That's the concept of mutability. It can change. And what we did is we gave it deps.storage. Storage is sort of the underlying storage of our contract. This is where we store these items. So this item will eventually be stored in storage, but we haven't got there yet. But what is stored in storage is the contract version because we've just set it. And of course, we give it the contract name, which is the name, and the contract version, which expands to 0.1.0. And what this little question mark does is that it unwraps the value. So it asserts, what you can imagine here is, as it returns an STD result, we want to unwrap it to assert that it succeeds. this is a pattern you get used to with Rust. Is quite often things will return results which can error or be okay. Unwrapping means assume success. So if this ever errors, which it shouldn't do unless there's been some cataclysmic storage failure, it will error the instantiate, and the instantiate will fail, which is exactly what we want it to do, because if we fail, we don't want to carry on. So did I lose anyone on that? Because that is some more boilerplate, but it's good practice to do that first thing in your contract, because it allows people to identify your contract. And if you've ever used the Juno Mint Scan Explorer for smart contracts, this line is how they set up the values that then populate that Explorer, how you can see the names of the contracts. That line just did that for us. So any questions on that before I carry on, where we're going to actually start writing our own code? Okay, we got a thumbs up. Right, I'm going to carry on then. Any questions, I'll stop and get to them. So
I don't know if too, but at the end we'll have like a session where everyone can unmute their mics if you want to ask questions in a less annoying way than typing. So we can always circle back on stuff later.
Yeah. Okay. So now I'm going to talk through the rest of the arguments. So env is of type env, very helpful. And what this does is it stores a few environmental variables around the contract. So you have the contract itself. So if we wanted to access our own contract address, we could do that. And the block, which is the block height and the block time, as in the time right now of the block, and the chain ID, so the chain that it's running on. And then the transaction, which is some optional transaction info, which gives you some metadata around the transaction, which is very rarely used, but it's there if you want it. So that'll contain some metadata with the transaction, but it's not always there depending on the type of transaction, which is why it's an option. Info, which contains some metadata of the message. So here we go. This will make more sense. Sender, which is of type address. This is the person that sent the message. So if you're instantiating a contract, this will be your address. And you're probably wondering, oh, why don't we use that for the admin address? We could if we wanted to. It's just I like the idea of having customization. And then funds, which is a vec, which is a list of coins. When you execute a transaction on chain, you can send funds along with it. These funds are what are sent along. And in this case, we expect it to be empty because we don't expect any funds to be sent. Say if you had a route where you needed to pay, you would query that funds for the specific coin you want. And say if I wanted someone, if they needed to pay 10, I would just check that value. Did they send 10 of this coin? And then message here is the actual instantiate message we just defined, which should have admin address. So what we're going to do here, if that all made sense to everyone, the info is metadata around the message info, which has who sent the message and what coins are attached, what are they paying. Env has some environmental data around the contract and the blockchain. This is block height, block time, the chain ID, and the contract address itself. And seldom used is the transaction data. And then deps mute is the dependencies, but it's mutable, so you can write to it. So now that we have this message and all the arguments defined, we're going to start writing some code. So we're going to define a variable here just to store something. Validated admin address. I like to be verbose with my variable names because I'm following you through. Guess what this is going to store? We're going to validate the admin address and we're going to store it in this variable. So how do we do that? Well, we use this deps variable because deps has some API routes which are stored under API. And then it has something called addr validate, which you can guess validates an address. And then you're wondering, what do we need to pass into this message? This function call. Well, we need to look into our message, and then we need to go admin address. And as you can see, it's erroring here. This is because it expects, if you look here, the and string, which is the address of a string. All we need to do in this point, because this message.admin address is of type string, we just need to prefix it with the and to pass it the reference to it. And then, of course, we need to semicolon it. As you can see here, we don't store an address yet. We store std result. So like above, we're going to use a question mark here to assert success. This means it will error out if the user passes an invalid address, which I'm going to write here. This could be any way you want it. It could be me giving it a Cosmos address on Juno, or it could just be me giving it the string foo, which will fail because that's definitely not a string of bytes. So now we have that. What we're going to do is we're going to define another variable. This one's going to be config. So you know that this is going to probably contain our config, and we're going to define a variable. So we're going to config, which should import it up there, which it does. And it's erroring at me at the minute because I'm missing the admin address field. Now, usually I would just use this and it would populate it for you, but I'm going to write it out manually just so I don't lose you guys. So what goes here? Well, we have a validated admin address. So we're going to just give it the validated admin address. So now we have created a config with our validated admin address above. So any questions on that part? Sort of this, what this does at a high level is it validates the address, and the question mark means that it asserts success and will error out if it fails. So we know that this address is valid, which is why we can store it in the validated admin. We can store it in the config. And as you can see, this function returns type address. That's because it's done the validation, so it just gives you back address. And then we go through, we define the config, which is this is how you define a struct in Rust, sort of instantiate a struct in Rust, and just give it, we set the admin address to validated admin address. Any questions on that endpoint, or am I good to carry on? Okay, so now we have this config variable. We defined it in state, right? We defined it as an item in state. We need to store it in state so we can refer back to it. So what we do here is all caps config, because this is our item, which imports it up here. We're going to config, which is the item, .save. We need to give it storage again, which is how you access the area where it will be stored. We need to give it that. And we need to give it the config again, so that it knows that it's storing config. And similarly to the string above, it wants it by reference. So we prefix it with the and symbol, just to give it the address of the config. And also similarly to the others, we question mark it because we want it to assert success. And how you can tell if you want to question mark something is that it returns std result. So if you hover over anything or use your IDE, you can see std result of type address. That means it's a address if it's okay, but it's wrapped in an std result, so we need to assert success. And then this is all the logic we need so far for our instantiate route, which we're going to finish up just now. So this unimplemented can go because we're getting ready to finish up. As you can see, the return type of this function is result. And this result can either be a response or a contract error. So a contract error is if it fails. This is okay. So we've reached the end of this, and we know this is the standard flow of execution, so we know it's okay. So we can use the okay to wrap. What this okay does is that it creates a result, and anything inside it will be wrapped in the result. And as you can see, as it's okay, we want to return a response here. So we need to go response new to create a new response. And what this does is effectively it returns a result response. I can understand if people lost it there because that's very different to other languages. But what we're doing is basically saying, okay, this execution has been successful, create a blank response. And if we wanted to attach some metadata to our response, we could do that via the attributes, which allows you to send text metadata. So as this is instantiate, let's just tell it that it's the action that we took is instantiate as an attribute. So that means that will be able to be identified. So with that, that's the instantiate route done. You've written your first bit of code. So I'm just going to stop here for a second. Again, any questions, any queries, any concerns, anything that went on that you didn't understand, I can go back and explain. If there's no questions, I'm going to just jump on to the next section. Which
recommend for people, if anybody just does, I think we're looking pretty good. I haven't seen anyone note this, but if anyone feels kind of totally lost and they're just kind of hanging in at this point and don't want to ask a question because you're kind of that level, if there's something that just wasn't explained in a way you understand, that even when you go back and watch the recording you'd like more clarification on, again, I'm sure someone else in here has that question, so don't be afraid to toss it in chat, and if it's not pertinent, we just might get to it at the end, but don't be shy. Sorry, Callum, you're killing it though.
No, don't worry. That's a good point. So I've written this code and I tell you that it works, but I haven't shown you that it works, which is a completely valid concern. So how can I show you that it works? We're going to write some unit tests, and this is very important for smart contracts in general. The unit tests is how you sort of test that everything's in the state that you want it to be. So what we're going to do is, when we saw this, when I first showed you this file, you might have seen there is a module called tests, which is blank at the minute because there's no tests. And it's flagged with this, which means it's only going to compile if it's testing. So we're going to expand this and we're going to start defining some tests in here. So how do you define a test in Rust? Well, you give it the little macro #test, and we're going to call the test instantiate. That makes sense, right? We're testing instantiate, so we call it test instantiate. And we're going to need some testing helpers in here, which CosmWasm defines for you. So what we're going to need is to do something in testing which is called mocking. It's what Timmy does to me actually all the time, but in a different context. So mocking is the faking of a value, and what mocking does is it populates a testing value. So we need to mock this because this is given to us by the chain. We also need to mock this, and we need to mock this. So what I'm going to do is step by step handle that. So we're going to call it deps, so it lines up with deps above. And I'm just going to start typing, and we want to mock dependencies. As you can see, it lines up, right? Deps, dependencies. We'll get to the mute bit later. What we also need to do is mock the end, which has a helpful function, mock env, because you're mocking the environment. Finally, we also need to mock the info. As you can see, these names all line up. Mock info actually takes some arguments, as you saw there when I hovered over it. The sender, which is the address of the sender, which we can code to address 1 in this case, and some funds. We know we don't care if they send funds, so what we can do is just give it an empty array like that by reference. So this is an empty vec, a list. We prefix it with the and symbol because of course we're passing it by reference, we're giving it the address of it. So we have these values set up, right? We're missing one of those arguments, aren't we? We're missing the message, the instantiate message. So let's look into that. So, like these values, I'm going to call it message, just so they line up. This lines up perfectly one-to-one with the arguments here. As you can see, these are prefixed with underscores because they're not used. It's just good practice to do that. If something is not used, prefix it with an underscore. So we need to go equals. And how do we create an instantiate message? Well, it's like creating a config. So what we do is we do that. And of course, it needs an admin address. And this admin address is of type string. So this looks very similar to our config up above, but of course it's of type string. And how do we define a string? We can just do this, which actually returns the type and the string by reference. So currently that's of type and string. What we need to do is just go dot to string, and that casts it to type string. You could have also have done something like string : from, and then address 1, and these bits of code would have been the exact same. So now we have all 4 of these values. So let's call the instantiate message, the instantiate function. How do we do that? Well, you just call it. The beauty of CosmWasm is that it all just works, to quote Todd Howard. So we know we need to give it deps. So we do deps. And because these are owned deps currently, this isn't the correct type. We need to go as mute, which converts it to deps mute. This is just something you get used to, and you'll also have to do this for query route, but we'll get to that later. Next up, we need to give it env, which we just defined. So we do env. We also need to give it info. And then finally, we need to give it message. So, and we can semicolon that. We're going to quickly define a variable called res. Actually, resp for response. Oh, also, one thing I quickly forgot. The deps up here, we need to prefix it with mute, so we can actually cast it to deps mute. Just make sure you do that. That is something I forgot. So, as you can see, currently resp is of type result response contract error, which is the exact same as this. What we want to do is we want to unwrap it to assert success. And we can't use the question mark here because this function doesn't return anything. You can only use the question mark if a function returns result or std result. This unwrap just forces it to do that, which is effectively what the shorthand question mark does. But this unwrap is just something we have to do because our function doesn't return result. So as you can see, our variable named resp returns response. So how do we query for something? How do we know it's succeeded because we've unwrapped the value, but how do we know it's done? How do you know I've shown you that it's done the instantiate? We're going to do a quick little assertion, which is if these values are equal, fine, but if not, let's error and fail the test. So what we want to look at is resp.attributes. And if you notice above, we added an attribute. We added action instantiate. So we know this attributes object has to have one value. So we can use a little helper called attribute to create our own vec of attributes. Action instantiate. So this is now asserting that this value is equal to this value, which it will be if it's all gone correct. So enough talking, let's see if I can actually code. So hopefully if I run cargo test now, so I've switched to my terminal, let's just not lose people here. If I run cargo test here, it will run all tests within the project, which is currently just this one. It will build the project and then test it. So let's run this. It'll take a while because it's the first one. If it even works, which is a big if. As I said, if it even works, which is a big if. Okay, something has gone horribly wrong with this.
I'm kind of glad something has. I always like seeing troubleshooting. It's like a really good way to learn, actually.
Yeah, right. So does that work? No, there is definitely something going horribly wrong here. And the worst thing is, I've never seen this error before. So what I'm going to quickly do is I'm just going to regenerate the project because there is something going on here. I'm just going to quickly grab that. Just go. We go to the sequel, boys. We go to 0 to Hero 2. Just going to open another new IDE. And we're just going to paste the code what I have so far. Oh, okay, so let's just go back to... There we go. Oh, there we go. Yep, okay, right. It fixed itself. I just needed to be patient. So we're going back to the original, which is as it is. So it currently errored because the schema folder, which I told you isn't of importance, is actually being included in this build, and it doesn't know where to look. As you can see, it's like, oh, there's no state, capital S, in the state folder, which is state.rs. We can correct this by just changing this to config, and then changing it down here to config. And this should stop it screaming at us, hopefully. So if we run cargo test here, there we go. So after correcting this, all I did was change this was state. And then we also changed it here. You can see our test instantiate passed. It's okay. So we know that our instantiate logic works. Have I lost anyone in me jumbling around because I started panicking? Maybe I should have just kept calm and knew what I was doing. But what we effectively just did here is we wrote this logic up here. We mocked all the values we needed to, which is a common thing in unit testing. We defined the message, which we just had, and then we called instantiate and we unwrapped it to assert success because we expected it to succeed. And then we also know that we can expect these attributes, well, this attribute. So now we've set up our contract. Let's write something to it, shall we? So as I explained, this one's going to be a polling app, right? So what this means is we need to store polls. So we're going to go to the state, and we're going to add another state variable. But first, we need to define something like config. So let's copy it over. But it's not going to be called config, and it's not going to have an admin address. We're going to leave it blank for now. We're going to call it poll. And what this app will do is we're going to store polls. So we're going to create that. And as there's been multiple, what we're going to do is we're going to do a map. And we need to make sure it's a storage plus map. So make sure it looks like this on the import. And a map, as I said, maps from one type to another. So what we're going to do is we're going to do string to poll. And then I'm just going to quickly fill in the rest because this looks very familiar to above. As you can see, the namespace is the equivalent of a storage key. So what this does is it stores poll variables with a string index. So what this means is a string value can be one-to-one mapped to a poll value. If you're familiar with maps in programming, this should be very familiar with you. It should be exactly how you know it. It maps one value to another. So what do we need to make up a poll? So we're going to do pub again because it's public. And a poll needs a question, right? It needs to ask a question. And a question is a string, right? It's a string of characters, which is a piece of text. So that makes sense. Then a poll needs to have responses. As I said earlier, we're only going to have yes or no responses. So it's going to be very basic, what you actually can't vote for. But so we're going to have pub, because it's public, yes votes. And that's going to be stored as a U64, which is a number, which is an unsigned integer of 64 bits, which means it has to be above 0 because it's unsigned. That's more than the number range we'll ever need, but let's be safe. And memory, who cares? And if we have yes votes, let's also do no votes, which is the exact same, but with just a different shiny name. So we store the poll, but what if we want to actually no, we'll get to that later if we have time. We'll see. This has already run on a lot longer than I thought, but we'll carry on. So we've defined the underlying storage. So we've defined how we're going to store the polls on the chain. And what this is, this string on this side, the left side, what that's just going to be is it's just going to be the question. So what the mapping will actually look like, it'll be so. And it will have the question, which is the exact same, just for simplicity's sake. Of course, I know that keys could collide. This is just for the sake of example. So that is what the underlying storage will look like. I should quickly format this so it's actually readable. There we go. So this value will map to this poll. So let's jump into the messages again, because we need to create a poll. So here we are in message.rs. We have our instantiate message. Let's delete this custom message because we don't need it. We're going to create an endpoint. So this is an enum. The above one was a struct. So an enum is an enumeration, which means it can contain a whole range of values because there can be multiple execute message types, right? So what we do here is we have our create poll endpoint. What does this create poll endpoint need? A question. And that's it. That's all we need for this very basic contract. Did I lose anyone here? Because enums are slightly different to what we've seen before. But the reason it's an enum is because later there's going to be multiple execute messages. So we're going to implement vote, and we're going to give the the user away to their choice. So we're going to have choice, and that's going to be a string. But that comes in later, so we can ignore that. So I'm just going to comment that out for now. For now, we focus on this create poll. And what this looks like in practice is this. That's how an example execute message, oh, that should be execute message. There we go. That's how an example message will look, which we will see when we get to the unit test of it. So if I haven't lost anyone here, I'm going to jump into the actual implementation. So any questions before I move on? Any concerns? Any discussion? Okay, right. I'm going to move on then. So let's get to contract then and scroll up from our test, which we just defined. And this is where we're going to be looking in the execute endpoint. And we're going to delete that unimplemented because we're going to implement it now. First things first, these all look very familiar. The message, we're going to remove the underscores because we're going to use all of them. The deps we've seen before. I'm not going to repeat myself. It's mutable dependencies. Environment we've seen before. Info we've seen before. So as we know, this execute message can contain a whole range of values, although we've only coded one so far. Rust has a neat feature called pattern matching, which if we do match, message, and then expand a block, we can then match all the different types of messages. So execute message, create poll, and we can execute some custom logic on it. And we know a create poll contains a question, so we can expand that out. And then here we can insert some logic. So I'm going to quickly leave that there. I know it's erroring, but trust me, we'll fix it very quickly. We're going to define a new function. So fn for function, execute underscore create poll. This could have been called anything, but because we are executing a create poll message, that's why I've called it that. We're going to give it deps mute. We're going to give it all of these values, all three of these. So it's going to have env, and info, message info. It's also going to have one more argument, and that's going to be the question. So we're going to give it question string. And what is it going to return? Well, it's going to return the exact same, so we can just return directly. So it's going to return result, response, contract error, which I'm auto-filling just because I'm lazy and don't want to type it out. But your IDE should do something very similar. So that means we can call this function directly from here. So we're going to do that. Execute create poll, deps, env, info, question, which lines up exactly with the definition here, and lines up with these values and this one here. So what we're doing is if it matches the create poll message, we are calling execute create poll. You'll see when we add more types of messages, just straight after this one, you'll see what I mean by that. So now we can focus on this function. We know we just need to create the poll. So what do we need to do? Well, firstly, we need to let poll equal poll, and a poll has a question, and then some yes and no votes. Which we can create to 0 because no one's voted on it yet. That makes sense, right? So you're wondering, why hasn't he done question? And you can tell my IDE is screaming at me. You can make it shorthand. So that is equivalent to this, if they have the same name, which you can see they do. So we can just do that. And that creates a poll. Now what we need to do is store it on chain. So again, capital P, capitals now, polls dot save the deps.storage, because we need to store it in the blockchain storage. We need to give it the key because it's a map. We can't just store the value direct. As you can see, we need to give the type of key as string. And we said we're just going to reuse the question. So question is going to be the key here. And then we need to give it the value, which is the address of Pol. And we want to assert success here. As you can see, there's an error here. So use of moved value. When you move a value in Rust, values are immutable, so they don't want to be moved and used more than once unless you want to pass it by reference. We're going to do a very little quick fix here and just change that back to this. So that just deep copies this string so that this is fine. And then once the Pol is saved, we know we can exit out and we can just do a new response, add attribute. And this time action is going to be create Pol. So this bit of code is very simple, right? But you can see that I'm going to add lines here because it just makes it clearer to read. We create the Pol in memory. We store it on chain. Then we return to the user saying it was a success. And as we didn't use these values, we can prefix them with underscores. So did I lose anyone on that, or does that make sense? Because it looks very familiar to stuff we've seen before. Okay, right. I'm going to continue now quickly, but what happens for duplicate keys? Okay, so this is a limitation of our model purely for the example. If you have two keys that are the same, currently they will overwrite each other. That's actually a good example. Let's fix that. So we have the question. What we're going to do is, before we even create it in memory, is if pols dot has, we need to give it storage, that's default, question dot clone, because we know we can't move it. We don't need to unwrap it because this just returns a boolean. So if pols.has returns true, it means basically what we're asking, does the map have a key of this value? If it does, we want to error. And this is a good point. This is how you define errors. So this is how we define, wrong executions. So error, then we need to define, because if we look in this little result, we need to give it a contract error. We want to do contract error, and let's just do we want to do a custom error val. Let's just use a key already taken. And we need to cast that to string. And what we're doing is we're leveraging the custom error that's been defined in here, which I explained earlier. So currently, for duplicate keys, it'll error out, which is a limitation of our model. We probably want people to have pols with the same question, but for the sake of example, let's just keep it simple. So I've shown you and I've written code that I'm certain that works, but again, I need to show you that it works. So we're going to go down to our test, and we're going to define a new test. And this test is going to be test execute. No, just test create Pol, because we're creating a Pol. So we're going to copy the code from above. We're just going to reuse this because before you execute a contract, you need to instantiate it. So and that just ensures it's all set up correctly. But yeah, thanks, We Are Automatic. That was a great question and something I'd completely forgot about, so you reminded me. So we've instantiated the contract as we saw above. We're not going to do the assertions because this is covered by that test and we don't want to duplicate code too much. he says while copying and pasting 5 lines, but you get what I mean. So now that it's set up, we want to do something similar again. What we need to do before though, because we're going to reuse some values, we're going to put clone on info and environment, just so we can use them again. So let message. In other languages, you wouldn't be able to do this, but Rust allows you to redefine variables in the same scope. So what we're going to do now is execute message, double colon, because it's an enum, create poll. And we need to give it a question. And I'm just going to use the question I've been using throughout. So what we've done here is we've created an execute message. But now we need to execute it. We already have the 3 other variables up here. So let's execute it. So we're going to do similarly to above for instantiate, but with execute. We're going to give it depth as mute. We're going to give it env. And we're going to give it info. And then finally, we're going to give it this message, which is just message. And then we're going to unwrap to assert success. And similarly to above, we're going to check the attributes. And we expect this to be, as we defined it above, action, which we have already from above, create underscore poll. So this should show that we create a poll on chain, because the test should pass. So you can see earlier, we only had 1 test. We've now defined another. So I'm just going to clear quickly. And we're going to run cargo test again. Oh yeah, there's a slight mistake in my code, which the test has exposed. Which some of you may have noticed if you're more technical or know what you're doing, but luckily the compiler's even given me the solution, which is this. You might have meant to return this value, which I did. So we need to prefix it with return and give it a semicolon. So we need to go back up here to the error and go return the error. And now that just returns the error. So now if we test, there we go. You can see that all goes through okay. And it's even giving a little advice. It's like, this is never used, so prefix it with an underscore. And specifically, this is this variable, because we do never use it. So let's do that. Did that make sense to everyone? Does creating a poll make sense? Before I move on, so that is the success case. We're going to write another test shortly, but I'm just going to quickly put a stop in here if anyone has anything that they need to ask. I'm going to take the silence as, yep, Callum, you're doing an amazing job, carry on going. So, we're going to define another quick test. Oh, actually, we're not. Maybe, yeah, let's do it. We're going to do it. We're going to live on the edge. We're going to be wild. So, we're going to build on from this test. As you can see here, we don't have full test coverage. We don't test this custom error. So we're going to test that. Helpfully, in this example, we've already created a poll and we check that it works. Now let's do it again. And it should fail this time. So it won't get to this. We need to clone these values as we're using them again. But as you can see, we have a message with the exact same question. So when we unwrap it, it should fail, which I can show you it. I can show you it right now. And there we go. It failed. Panicked at called result unwrap on an error value, and then it has our error key already taken. So how can we assert that this has? So unwrap is to assert success. If only there was something that we could use which did the same for errors. And we're also just going to prefix this with underscore because it's never used. Well, you're in luck because there is unwrap underscore error. And all that does is just it unwraps the error. So we can assert that we got the error that we wanted. So let's run this test again. And it passed. So now this function here has 100% test coverage. We've tested the case where we have duplicate keys, and we've tested the success case. So we've created a poll, but how good is a poll if you can't vote on it? So let's do that, shall we? Let's vote on a poll. Let's head back to the message. As you can see when I was explaining, I already defined the message, but for people who didn't write that down, we just define a vote, and we have a choice of type string, which is going to be, in this case, yes or no. And actually, we also need to give it some more data. We need to know what question it's answering. So does that make sense? Because we need to identify what poll we're answering, and then we have our answer. So we're going to jump back into the contract if there's no concerns there. This is, so just to give a high level explanation, this is create a poll with the following question. To give a textual explanation, this is vote on the poll with the vote on the poll with the question with my choice, which is yes or no. So as you can see, our match error is erroring out, and it says match must be exhaustive. What this means is we don't have full coverage. So we need to add vote, and this needs to have a question and a choice. So this lines up exactly with our message. We're expanding out our message using pattern matching. So we saw this error before. I'm just going to jump below here and quickly define the execute vote function. So we've seen all of this before. Next up, we want question, which is a string. And then we want the choice, which is a string. And we carry on with the stuff we've seen before. We go result, response, contract error. So now we have the logic defined. Let's go up to our match statement and go execute vote and fill in these values, which is very similar to what we've seen before. And choice, there we go. So now we need to go down here. So first up, what if the user is voting on a poll which hasn't been created? Well, we need to error for that. So we're going to borrow the code from above. And we're just going to change the error value to poll does not exist. But we're currently checking that it does have a key, so it does exist. What we need to do is invert the value returned. And we do this in program by just adding an exclamation mark, which effectively expands to, if I go for, if I add the exact exclamation, if there is no poll with the key question, we want to error and tell the user that poll does not exist. So that makes sense. We're erroring out if the poll that they are attempting to answer does not exist. So next up, we need to check what their vote actually does. But now we know the poll exists, we can load it. So how we do this is we're reading storage here, which is let poll equals polls, which is our storage, dot load, which is loading from storage. We need to give it depth.storage as usual. And we need to give it the key, which we know is question. So we can go question. And we can bring back the question mark unwrap because we've checked if it doesn't exist. So we know it's going to succeed. We know it exists. And what we're going to do is we're going to make this poll mutable because we're going to update it. And how are we going to update it, you're going to say? So what we're going to do is we're going to go if choice equals yes, poll dot yes votes plus plus. If that, let's just do plus equals 1. There we go. That makes it a bit more clear. And then what about the no votes? We're going to do else if choice equals no, poll dot no votes plus equals 1. But what if it's neither of those? What if the user's just sent some garbage? Well, we're going to error again. And this time value is going to be unrecognized choice. So we've broken into this. Actually, there's probably a better way to do this to reduce duplication, which is what I'm actually going to do. So so that's overall what we want to do, but I'm just going to flip the logic a little bit just to make it a little bit cleaner. So if choice does not equal yes, and the double ands mean and logically, does not equal no. So I'm just going to write a comment here. If choice is not yes or no, we're going to want to error. Else, we're now going to go, we know it's yes or no, but we don't know which one. So we're going to go if choice equals yes, yes votes plus equals 1. And because we know it's either yes or no, we can now just do else no votes plus equals 1. And we're exactly where we were. But we just need to, the reason this is all being underlined in red, that's true actually, that would be the more Rust way to do it. You can tell I'm doing this live, and that's probably what the compiler will recommend to me. So what Reese has made is a good point. You could also, using the match case earlier, go choice if match supports strings. So we go yes, no, which I'm just filling with empty brackets, and then we do underscore, which matches any case which isn't defined above. So anything but yes or no, we're going to do that. Error. So this is how you do it with a match case. But so I'm going to stick with the ifs because I've already got it coded out and I'm lazy. But that's how you do it with a match case, and we're going to just proceed how it is. So we've updated the polls value. Let's save it. We need to save it again. So we've seen save before. And that's exactly how we saw it before. Oh, I forgot to clone it up a bit. So make sure you clone it up when you load it. We're just skipping over efficiency here. There is a better way to do this, but this just makes easier learning. You know, let's not run before we can walk. We then, if the choice is not yes or no, we error. If it's yes, add to the yes votes. If it's no, add to the no votes. And then we save the updated poll the chain. and then the response is something we're used to. So we're going to add an attribute action vote, which we've all seen before. So there is some flaws in this. People can just vote as many times as they want, which is not ideal, but for the sake of this example, it's fine. We're not counting for an election. This is just a toy app that I'm showing you how to write CosmWasm code. It's not the end of the world if people vote multiple times on do they love Spark IBC, as much as Timmy probably thinks otherwise. So we're going to go and we're going to test this function. So again, I've written code. I've told you that it works. Now I'm going to show you that it works. And once again, we're going to have to copy some code from an existing test. As we know, we need to create a poll to vote on it. So we're going to copy everything up until the assertion. And we're just going to quickly prefix this with an underscore. Did I lose anyone there? Just because I know I copied a block, but I'm doing it for saving time. I copied everything from the first line of test create poll to the execute call where we create the poll. And I'm just going to click on, we need a poll vote on. So there's four main cases here, as we can see. There's we vote on a poll that doesn't exist. We vote with a choice which isn't yes or no. We vote yes. We vote no. But these ones can be merged because it's just the correct case. So there's three main avenues. The vote on a poll that doesn't exist, vote an invalid choice, success case. So let's handle the success case first, right? So success case, which is we vote on a poll that exists with a valid option. So message equals execute message, vote. The vote needs a question, which we're going to paste from above just to make sure that it's exactly as we need. And we need to give it a choice, which I'm going to give it yes, because Timmy will have a go at me if I don't say yes. So this vote, whoever is voting here, whoever is voting here is voting yes to do you love Spark IBC. So what we can actually do is borrow this code from above, but we're just going to quickly remove the underscore because we want to perform some assertions here, which is, as we've seen before, assert equal resp.attributes to a vec to a list of attribute action vote. Sorry, some typos there. So this test should now work. So let's run the test. And there we go. The one third of our test vote works. Let's do error case number 1 now. Which is, we vote on a poll that does not exist. So again, I'm just going to put some code from above. And we're going to change the question. Simple enough. That poll has not been created. So this should error. And as we know, we can then prefix this with underscore and replace this to unwrap error because we expect it to error as we saw above. As I glance over that quickly, we are defining an execute message of vote for a question we know that doesn't exist, but with a valid choice. But it should error and tell us the poll doesn't exist. So that's why we're unwrapping the error here. So let's run test again. And there we go, it still passes. We've got 2 out of 3 of our test cases, so let's go for one more. Error case 2. We vote on a poll that exists, but with an invalid choice. And an invalid choice in this case is something which isn't yes or no. So we need to change this back to do you love Spark IBC, because we know that poll exists, but we need to change choice. So choice could be maybe here, and this should error out. And as we've already copied this line from above, it's already unwrapping the error. So if we run the test again, as you can see here, all the tests pass. So we have our write endpoints for our contract. But you don't always want to write on a contract. How do we get the data out of a contract? This is when query message comes in. Again, like above, I'm going to implement 2 query messages, and then we're going to add tests to them, which are going to go with our existing tests. So a good query would be get poll. We want to get a poll with a specific question. That makes sense. But before we do that, we're going to jump down to this variable, and we're going to rename it. This is going to be renamed to get poll response. And I'm just going to put a comment. This is what we return for our get poll route. And what this is going to have is it's going to return a poll of type option, because the poll might not exist. Poll. And what option means is it can either be, it could be null, or a poll. And null just means no value. It's never been set. So we're going to jump into the query route here, but did I lose anyone here? Option can be confusing, but it's just the functional way to put it can either not be there or it can be populated. And the query message enum is very similar to execute message, except it's for read only. So I'm just going to jump on through, and we're going to scroll up from our test, and we're going to go to the query endpoint. We're going to expand this. We're going to underscore everything, technical term, and we're going to talk through what this message does. So deps here is different. It's just deps. It's not mutable. It can't be written to. This is a read-only endpoint. You can only read data. You can't modify the data with a query. The env is exactly the same. It's just some environmental data around the contract. And then the message, this time it's just query message. So like above, we're going to do a match case on the message. And we're going to do query message, get poll, and we need to get the question out of it. Again, this is looking very familiar to the execute point. Even now to the point, we're going to jump and we're going to create the query, get poll function. This is going to have deps, env, and it's going to have a question. As you can see, there's no info on this. The reason being is because this isn't a transaction on chain. No one is actually sending it. It's just querying the chain. That's the reason it has no money being sent. It has no address attached to it. Then we're going to get to the return value, which is std result binary. So this is going to be an encoded value in binary. It's going to be our response, but encoded down to binary. And std result is simply just so you can assert success. It's okay, here's the binary. And if it fails, it'll just error out. So what we're going to do is we need to get a poll. So we're going to get the polls. And instead of loading, because loading assumes success, we're going to use another function called mayLoad. And we're going to give it deps.storage. And we need to give it the key, which is question. As you can see, this already returns something different. It's std result, so we need to question mark unwrap it. But it returns an option poll. And as you know above, this means it can be null or our poll. So this means we can then use the helper function toBinary, which converts stuff to binary. And because we need to give it by reference, we need to do, what did I actually call that? I've actually already forgotten. It's called get poll response. So we need to give it get poll response. And we know in here we've got to give it poll, which we can do the shorthand for. And I actually messed up here. This needs to be public. So sorry for jumping around there. May have lost a lot of people. I changed this to public because we need to be able to set it. And then what we did is we loaded the polls. We may load it so it can be null or the poll. And then we convert to binary our get poll response poll. And then we can go here, we can do query get poll, we can do deps and question. So, typo there we go. So how can I show you that this works? We already create a poll. Let's scroll down and let's add the test in. So this is the success where we create a poll. Let's do another message in between. So this is going to look different, so I'm going to take it slower. Let message equals query message, because we want a query message, get poll. We know it needs a question, and we know the question we're looking for here is this one. So we have the question now. So similarly to above, we're going to do let resp equals query now instead of execute, because we're querying it. Deps dot, and instead of as mute, because that's mutable, we want to use as ref, which gives the unmutable version just as a reference. Env.clone, because we need to give it the environment, and message, which we've just defined. And let's unwrap that. As you can see, we've got binary here, but binary is pretty useless. We can't interpret anything from it, so we need to decode it. So what we need to do is we need to do let get polls response, just giving it a verbose name so you know what it is. And we need to type it just so it knows what it is, which is get poll response equals from binary, which is the opposite of the to binary function. It takes binary and it gives back the typed value. And we're going to give it resp, which is of type binary, and we need to unwrap it. And we also need to give it and here. I believe we need to do it like that. So what we did here, we queried it and it returned the raw binary. We're then decoding the binary into a get poll response using the from binary message and unwrapping it because we expect it to succeed. Then what we need to do is do an assertion again. So let's do this assertion then. Get poll response. Get poll response. We expect the poll to be of type option poll, so we need to wrap it in a sum because like OK and error, sum is the shorthand for defining an option. And I'm just going to fill out this with default values quickly. And we're just going to fill that in because we know it has had no votes because we're just testing it in the create poll. I'm just going to quickly run this test and show you that it's working. Never mind, it's not. But that's because I've renamed the custom response. So I need to go into the schema again and just rename this to get poll response. And then down here, get poll response. Just going to quickly leave a comment just so that it's clear where I left my modifications. And then we're going to go back to the contract. Actually, we're going to go back to the terminal and test it again, and it worked. It asserted that this value on the left is equal to the value on the right, which it is. We can also use this code, if I just copy it quickly, to test when we vote. So as you see in the vote test, we do vote. So let's paste this code, and we know that the question is the same, but we voted earlier, we voted yes to this. So we expect yes votes to be 1 now. Let's run this code and just see. And there we go. It's not the most visual, but we can see that we've created a poll, we queried for it, and then we also voted on it, and then we queried for it again, and we saw that the yes vote had gone up by 1 because we voted on it. We could do this again and again, keep on voting yes, and this counter would just go up. So, before we wrap up, we're just going to do one little route. As you see, the config has actually not been used in this tutorial at all. We're going to use it for a very basic route. This route is going to be called getConfig, and it's going to take no arguments. And we don't need to define a custom response because we're just going to return the config directly. So we're going to go in here, and I'm going to show you a one-line response here. We don't need another function here because this is very basic. All we need to do is convert to binary. We need to give it the address of something. So we need to go and config.load deps.storage, and we need to unwrap it there. What this is effectively doing is if we break it down chunk by chunk, load the config, decoding it to binary. This just gives us a way to read our config. Let me show you that now in our instantiate test. Let me just quickly add a clone on the environment there because we need that. We need to go message equals query message get config because we want to get the config. Then what we need to do is we need to go let resp equals query deps.asref because it's a read only end, and then we need to give it message, and then we unwrap it because we expect it to succeed. Then we need to get a config. We need to set the value of config so it knows what it is from binary and resp. And we need to unwrap this to assert success. So now we have the config. We're going to perform a similar assertion here that we did earlier. And we know, as we said it above, admin address needs to be of this. But as it's now an address type, we need to use the address : unchecked helper, which takes a string and just converts it to an address. So now if we run cargo test, this assertion should still pass. And we just check that our contract has been set up correctly because we query for the config after. And this brings us to a close for our basic polling application. I hope you actually learned something here, but we're going to open the floor to questions here. But yeah, I think this is a good point to close. We've got the basic foundations of a polling app. We've created a poll. You can vote on a poll, and you can also check up on a poll. You can read the values associated with it. So I'm just going to pass over to Timmy here, because if he wants to take over to lead the floor, feel free.